show what you'll need to measure and mix two types of magnetic composites, one with an iron filings filler and one with an iron oxide filler. You'll want enough stir sticks, cups, and supplies for each team or group to do at least 2 batches of each composition type, 2 using the iron filings and 2 using the iron oxide. As I show here, I pre-measured and marked the plastic cups with the amounts for the iron filings composition. I set out measured portions of the borax and filings as well. Now it's up to you how much of this setup you want to do for your students, but this setup definitely saves time and cleanup. Blend the glue and water first, then the borax and water. You want the borax to be mostly dissolved as you can get it. You'll want the glue a very liquid consistency. Also, as you blend or mix the liquids, use fresh stir sticks. This will avoid contaminating the mixture and possibly causing the borax to start reacting too soon. Add the filings to the glue mixture. This is an important part of the composite composition and processing. Now, filings aren't going to blend. They are a hard, solid material. What you want here is to get them to disperse into the glue mixture as evenly as you can. Then pour the mixture into the bowl, getting all of the material to transfer as best as you can. I show using the stir stick here. Add the borax mixture to that, and you will see an immediate change in the material as the borax starts to interact with the glue. I start to blend the composite with my hands in a kneading fashion to get the filings to further disperse. You notice there is excess water. This would be an interesting discussion to have with your students and possibly an area they would want to explore with composite composition. You can say, you know, what if you added less water and see what they come up with. Once mixed, let it sit to cure. I do believe that creating this magnetic composite is an art. It should not stick to you or the table surface. It should be more like Play-Doh or putty, not too firm and not too gooey. Trust me, you'll know when it's right. Here I repeat the process with iron oxide with one big change. I found that adding the oxide before allowing the borax to interact with the glue resulted in a very wet, non-cohesive, way too stiff and hard composite. When I changed the procedure to add the oxide after the interaction started, I got a much better composition. So it's up to you what you do with this. Have your students discover this for themselves or direct them to process in this way. You know, it could be a good learning experience. And this is another opportunity to discuss processing and composite composition. Materials too, filings versus oxide. The explanation can be a number of things, including speculating that the oxide may be interacting with the cross-linking caused by the borax. I have nothing to support that claim, but it is one observation, and it coincides with the old chemistry rule that there is an order in which chemicals should be added. Totally up to you. And again, let it cure, and you should get a very good result. Investigation suggestions that I'm going to make here are really about observing the magnetic composite behavior, its shapeability and flexibility, as well as the magnetic field strength and the attraction to the magnets. It's important that you start with a fully cured composite material. You'll be able to tell the difference when it's cured and when it's not. And the type of magnetic composite that you use for these investigations is up to you. I used iron filings and iron oxide. First investigation I call the magnetic attraction. It can be used to compare the influence of various magnet types or magnetic fields. You want to place several types of magnets around the composite material, the one with the filings and the one with the oxide, and then just observe. I use neodymium, horseshoe, and bar magnets. You can vary this investigation by stacking your magnets and observing different attraction strengths. In this example, you can see I used 5 neodymium magnets. I stacked them to demonstrate the most observable result. It's pretty dramatic when you do see it. Another variation with this investigation can be to vary the amount of iron filings or oxide used in the composite composition. And you'd have to do that, when you come to this station, to this investigation, you'd have to decide how you wanted to do that. But varying the composition will yield different results. Also, by varying the composition, you demonstrate that when designing a composite, you have to consider the strength of the filler. The second investigation I called magnetic strength. I think you can use it to demonstrate the magnet's pull on the composite. You want to observe the overall weight change on the scale and the speed with which the composite is lifted from the base of the scale by the magnetic field that you apply. You don't see anything for a while, but you can watch the scale actually decrease in weight, and that's kind of the observable effect. Observing from the side profile, like I'm showing you here, you can see the composite being pulled up by the magnet. You can see the change, and it's pretty dramatic from this position. The change in weight can be observed, the change in shape, it's kind of a little blobby shape. And where this applies to the module is it's a behavior of the composite. Investigation with iron oxide to show the difference in pull. It shows a couple of things in this clip, how to weigh. Your students can see how you can weigh and how you can pull portions of the composite off to get the correct starting weight. I used about 140 grams. I also wanted to point out the structure of the bridge in this clip. I used a stack of condiment cups for the piers and a craft stick for the bridge. Pretty easy to do. So first, I tried to get the same behavior as with the filings, and you can see the change in weight. And when you go to the side view, you can see the pull as well, but only after you increase the number of magnets. So that's another thing you can get the students to experiment with. They can decide how many magnets to use, amount of composite to put on the scale. There's a bunch of different things they can try here. But basically, the pull difference that you see in this investigation between the two types of composites demonstrates that composition design affects its application, especially those applications requiring the ability to pull a composite into or through a device. There's some applications like that that your students will be learning about. So the other little thing I wanted to point out here is that you can put the composite sample in a cup because it will slowly spread over the edges of the scale. Okay, this investigation can be used to show the composite's amazing abilities, such as being able to be deformed, stretched, and shape controlled. These properties make it applicable to the design of new structures for circuits or devices, some of the things that you'll be talking about in your class. You can see on both samples the straw laid on its side. The magnets just sucked the composite right in. You want to show how the composite can be injected, if you will, into these different shapes. And it's easy to see how the composite fits into small shapes with this segment of the straw, about 1.5 inch segment of straw. The other thing you can point out at any time is the flexibility and different properties of the composite. You can bounce it, stretch it, whatever, and then discuss those properties with your students. And then you can show how you can segment it, just cut into it. I use a cookie cutter here. You can also see that it holds its shape for a little while. That's something else you can discuss with your students. And also how it goes back into its original shape. That cutout piece just kind of goes away. Compare the two different composites, their behavior with this one. The behavior differences between the two samples can be used to, again, demonstrate design considerations when you need to achieve a different composite behavior, such as a stiffer shape. If you notice with the oxide, the shape was a little bit stiffer and it was tougher to cut. So this investigation, I just wanted to show you viscosity testing with a funnel. That's typically how you test a material's viscosity. You can set this up pretty simply with just a funnel and a cup with a hole cut in the bottom. That's all this is. You can also show the shapeability with the funnel.